D is a little bit different because we have the absolute value of 3x minus 2 is greater than 0. Well, let's take a look at what that actually means. We've got an absolute value, which, let's see, is going to be positive most likely, but could be 0 somewhere. And we're asking, when is this absolute value going to be greater than, what value is on the other side? 0. Well, it's almost, and I do mean almost always greater than 0. Almost, let's be careful, almost always greater than 0. Remember that greater than 0 means positive. So the issue is going to be, when does it actually just equal 0? That's going to be our only issue of when it is not greater than equal, or is not greater than 0. So let's take a look. So the only issue is that we don't want 3x minus 2, we don't want it to equal 0 because we want greater than 0. So let's find out when it actually does equal 0, because that's what we don't want. So we'll solve this like we would normally by adding 2 to both sides, which will give us, let's see, 3x cannot equal 2. And then we'll divide both sides by 3, which will give us that x cannot equal 2/3. So what this means is that the absolute value of 3x minus 2 will be greater than 0 everywhere but at 2/3, because at 2/3 is when we actually, the absolute value will actually equal 0. So anywhere else is fine, but 2/3 is not okay because that's where I'll equal 0. So let's go ahead and draw a number line. Let's put our 2/3 there. So what this means is, again, anything to the left, anything to the right, just not 2/3, which means I'll have this little gaping hole at 2/3. Because at 2/3, it's, if you remember the shape of the graph of a V shape, it looks something like this. It probably means that at 2/3 that's where we're going to be hitting the x-axis, because that's when we will be equal to 0. So when am I greater than 0? When I am above, but here at 2/3 is when we're actually going to be equal to 0, and we don't want to include that value. So how we're going to draw that out in interval notation is that, reading it from left to right, is, we'll start on the left-hand side, is negative infinity all the way up to 2/3. So that'd be negative infinity up to 2/3. Again, parentheses, because we cannot include 2/3 because we want to be greater than 0, not equal to. And then we'll draw our little U for union. And then we'll do our other side of our graph, which is the right-hand side here, which will start back at 2/3 and continue off to infinity forever. Again, we can't include 2/3. And that's our final answer, is saying everything to the left of 2/3 and everything to the right of 2/3, but not 2/3. Let's take a look at another example that's a little bit different. We've got the absolute value of 3x minus 2 is less than or equal to 0. So again, we've got our absolute value by itself, which is wonderful. We know that an absolute value is either positive or 0 at the smallest. So the first thing it's talking about is, when is this less than 0, meaning when is it negative? And when is an absolute value negative? Never. So this little part of this inequality is never going to happen, which means the only part of my inequality I'm actually worried about is when I equal 0. So, well, that means I'm worried about, when does 3x minus 2 actually equal 0? We already solved this up on the last problem. We said that happens when x equals 2/3, and that's because you'll add 2 to both sides and then divide both sides by 3. So this particular problem is actually saying the reverse. Is we've got the same kind of picture going on, but instead of everything but 2/3, we're saying the only answer is 2/3. Again, because if we were to look at this graph, here's at 2/3, here's our V shape. Less than or equal to 0 means when am I below or equal to the x-axis? Well, notice I'm never below the x-axis. However, I am equal to the x-axis here at 2/3. So our only answer here is the 2/3. How do you write this out properly? Is our answer is just the value 2/3, nothing else. When you've just got a couple of numbers to include, we use the set braces. So we'll use set braces and just give the value 2/3. But that's it. So we do need to be careful when we have absolute values and we're talking about any number that's not just a positive value, when you've got 0 or something negative. Then you're looking at a special case and you need to take a little bit of extra care and kind of think of it more from a practical approach like we were here. The next couple of examples have us translating written in word statements into mathematical symbols. So part of how to do this is realizing that whenever you see absolute value, and we're talking about the difference of two numbers like we see here on this next part, is what we're talking about, remember, is that absolute value gives us the distance between two things, especially when you're subtracting them like this. So when we have the absolute value of a minus b, it's actually giving the distance between a and b. So that's what we want to kind of realize, is that it gives the distance between them. So then what we can do is translate statements like the next one. So on this first one, in A, we've got the x is within 0.002 units of 10. So we're talking about two things in the distance between them. Even though the order is kind of strange, what we're talking about is the distance between x and 10. So because we're looking at the distance between those two, that's what's going to go inside of our absolute values, their difference. So we'll have our x minus 10 that will be inside of our absolute value, because those are the ones that I'm worried about their distance between. What do I say about the distance between them? That it needs to be within 0.0002 units. So that means that this distance, this absolute value here, needs to be smaller than 0.002. So what we'll go ahead and do is put our less than symbol, because we want to be within or less than 0.0002 units, and that will be our answer for A. Now let's take a look at B. In B, we've got that y is no more than 8 units from 22. So on this one, we're talking about the distance between y and 22. So we should be starting out with the difference between y minus 22. And because we're looking at the distance between them, we're talking about its absolute value. And what do we say about its distance? It should be, let's see, no more than 8 units. Which it should be, what that should mean is that the distance should be less than or equal to 8, because it says no more than. It means it can be 8, but it can't be more than that. So that's going to be our answer for B. But that's it. So we do want to make sure that you know and understand how to translate kind of statements using absolute values.